Hello everyone, today we will be building some Mechatronics circuits with a DG01D-E motor with encoder. For this first circuit, we will be needing the FQP30N06L N-channel MOSFET. Additionally, we will also be needing the FQP27P06P channel MOSFET. The first circuit we will build with these components is known as the H-bridge circuit. MOSFET stands for metal oxide semiconductor field effect transistors, and the main difference between N and P channel MOSFETs lie in their doping characteristics, but that is beyond the scope of this video. In this video, we want to focus on how we can use the MOSFETs as switching mechanisms in the H-bridge circuit. The H-bridge circuit allows us to switch the polarity of the power supply, or in other words, allows us to change the direction of current flow that goes through the DC motor. If we are able to change the direction of current flow that goes through the DC motor, this means we are also able to change the direction at which the motor rotates. There are two mechanical switches present in the circuit, S1 to the left and S2 to the right. If we press S1, the DC motor will rotate clockwise, whereas if we press S2, the DC motor will rotate counterclockwise. We need to be careful not to press both switches at once since we don't want to short off the circuit. Now let's see these two switches in action. Everything is fine and dandy, which means we are ready to move on to the next circuit. This next circuit will use the Arduino Uno R3 as the microcontroller. Additionally, we will also need the 1N4001 diode. This will allow the current to flow in only one direction. The next circuit we will be building is called the PWM control circuit. PWM stands for pulse width modulation, and it is a method of treating digital signals as analog signals through the use of pulses. In order to control these pulses, we will be changing what is known as the duty cycle. The duty cycle is the ratio of how long the signal is on versus how long it is off. For example, if the duty cycle is 100%, the signal will be on all the time. For this circuit, we will start with a duty cycle of 100% and go all the way down to 0. If you listen closely, you may notice that the pitch of the DC motor also changes. Thank you all for watching, and stay beepish.